standard academic intro. Oh wait, I can't read my writing. Angela Speck. She grew up in Britain, and every time she talks about growing up near London, all I can ever think about in the back of my head was, oh, it must be somewhere just south of Hogwarts, because all she ever talks about is Star Wars and Harry Potter. After that, she did the important bit, and she went to the University of College London, where she got her PhD. And after that, she jumped the pond and came over to Mizzou, where she's done a couple things, I guess. She won a prestigious career award when she got here, which is an NSF award for a young investigator. After that, she established Cosmic Conversations. Has anybody here ever been to Cosmic Conversations up at the observatory? Yeah. She established the Astrophysics program in the physics department, which again is a monumental achievement amongst all of the rigmarole of trying to get a new department started or a new program started on campus. And additionally, she most recently won a Kemper Award, which is sort of recognition that she has a little bit of ability to communicate with the general audience, I guess, being the student audience. So it's safe to say that she sort of had a meteoric rise through the ranks at MU. Sorry, that was really bad. No pun intended, she rapidly went from the rank of assistant professor up to full professor. And all while having a multiple of different hairstyles and a variety of different nerdy Star Wars t-shirts along the way. But what does she do? That's the most important part, right? So Angela Speck she stares off into space and tries to figure out the life of planetary bodies based on what she sees as light comes back. And that's the really important part, and it's part of which I think she'll talk about tonight, is that she utilizes light, the types of light that come back from the solar system, to understand what's happening out in the universe. Okay? Now, the last thing I should talk about is why am I the moderator or your host tonight, besides just being somebody who is clearly very nervous about speaking on public. So, first off, one good choice for me is that I know almost nothing about astronomy or astrophysics or anything, so I can play the foil just as well as anybody here. But two, my own research utilizes light to examine not planetary bodies, but small bodies within the cell. And so we try to understand how the life of a given small macromolecule or molecule in the cell behaves. And so I have some insight into what she's trying to say most of the time. I have no idea what it has to do with Pluto, but I guess we'll find out tonight. And without further ado, I'd like to introduce Angela Speck. Some of us know her as Angela.
Okay, so I'm going to start and kind of give you a little bit of a historical perspective on the issue of Pluto. But the first thing that I'd like to do is to find out how many of you think that Pluto should be considered to be a planet? Yeah. Okay, so we have a mixture. I would say that there's an age divide going on there. But I don't know how many of you know the history of where this comes from. And so I want to kind of give you a historical point of view, and then I want to invite you to give me the reasons why you think Pluto should or should not be considered to be a planet. So I want to take you back in time a little bit, because one of the things that's weird about astronomy is that it's a really, really ancient field. We've been doing this for millennia. And because of that, we have some historical perspectives. And so, people have been looking at the sky since people have been people. And when you look at the sky, what do you see? You see stars. Okay. As we move around, as we spin, as the Earth spins on its axis, the sky seems to move. So if you watch say the Big Dipper seems to kind of go around in the sky, right? If you watch Orion, it rises and sets just like the sun does. And over the course of a year, you'll see different stars. But the thing that even ancient people realized was that there were some objects that you could see that didn't move like stars. So if you're looking at the Big Dipper, all the stars move around together. If you're looking at Orion, all the stars move together. But there are these other little objects that move. And those are the planets. And we've known about those since before we knew what a planet was. They were just something different from stars. So what you've got is these things are moving around relative to the background stars. Otherwise they look kind of like stars, okay? And you can go out and see with your naked eye, without any sort of telescope or anything, you can see the planets out to Saturn. So we've always known about them. They've always been there. They're not something that we discovered. They've always been there. They've always been part of our mythologies. They've always been part of our culture. And so up until the invention of the telescope, who knows who invented the telescope? I had someone whisper it somewhere. Galileo. Okay, so Galileo was the person who took the telescope and pointed it at the sky. He was the first person to use a telescope for astronomy. He wasn't the first. It was actually invented for the Dutch Navy. It was a military invention for using on ships on the ocean. And so he took a telescope, and up until that point, we never had any way to improve how we looked at the sky. So up until then, we've got 6 planets, right? We've got the Earth, and then we've got Mercury, Venus, Mars, Jupiter, and Saturn. And those are the things that we can see without any help. And then along come telescopes, and we can start to see more things. And so what's the first thing that's discovered? Anybody know what the first thing that was discovered out there? We can see Sirius. So in fact, the first thing that was discovered were the rings of Saturn, the moons of Jupiter. So we started to see some things that people had never seen before. And then we found another planet. And the first planet to be found was discovered by William Herschel. And it was very nearly called George. Because William Herschel was a British astronomer of German descent, just put it that way, and wanted to impress the monarch, who was King George III. And I'm pretty sure there would have been a lot of your ancestors that would have been very unhappy if we'd actually called the planet George. So we've got this planet. It gets called Uranus. It's already weird in terms of its naming conventions and all of that. It's already weird, and not just because you can make funny jokes out of its name. So all the planets, apart from Uranus, are named for gods in the Roman pantheon, right? So Jupiter is Zeus, and Saturn is Kronos, sorry, and so on. But Uranus is the Greek, not the Roman. And it also has its moons. The moons of all the other planets are named for things from Greek myths. So they all have names that come from different Greek myths, except Uranus. Uranus has moons that are named for Shakespeare characters. So it's already weird. It's also weird on many other levels physically. But this is the first thing that's discovered. Discovered in the late 18th century, 1780s. It's discovered. And that is the first planet we've ever discovered. Okay? We get to the beginning of the 19th century, 1801. And we're using telescopes and we're looking around. And there's another body that's discovered. What is it? We're not there yet. So it's not Neptune. It's in fact an asteroid called Ceres, except that we didn't know it was an asteroid. So you've got this place where you're seeing these bodies, and this thing is found, and initially it's called a planet. You've got a new body. It's in between Mars and Jupiter. The reason that we couldn't see it before, even though it's closer than Jupiter, is it's very small. So one of the things that happens in astronomy is, as Jason said, we only have light. We only have light to play with. So when we want to see things, it's really about how much light do we get. And when you're talking about planets, it's how much light is reflected. So when we see Jupiter, we're seeing the light come from the sun all the way to Jupiter and then bounce back to us. Okay? When we see Mars, the light hits Mars and bounces back to us. The asteroid belt is closer to us than Jupiter, but the bodies in there are so small that they don't bounce back that much light. They're just too small. So it wasn't until we had telescopes that we actually found these things. So we found Ceres. And then we found another one the same year, and another one a year later, and another one a year later. And within the first 50 years of the 19th century, we'd found 10 objects that were things kind of planet-like that were orbiting around in the same sort of region of space. And that was the discovery of the asteroid belt. If you can find a textbook from the early 19th century, you can find ones that have the solar system being Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus. We haven't yet found Neptune. Okay? Towards the end of that period, when we started to discover the asteroid belt, we also discovered Neptune. Okay? That was around 1850, 1846. So now we're moving out further into the solar system. Then we're going to take a little step forward, and we're going to get to 1930. And a guy called Clyde Tombaugh was at the Lowell Observatory in Flagstaff, and he discovered this body. And he didn't say, "Hey, I found a planet." He said, "There is a trans-Neptunian body." Okay? Trans-Neptunian just means past Neptune. So it was basically it. So we found something, and it's past Neptune. Cool. Okay. So that was the discovery of Pluto. And then it was named. And since then, and all of this comes with technology. So we start out and we can only see things with our naked eye. And then we have telescopes and we start to see more things. And we can collect more light. And now we've got things like the Hubble Space Telescope and other similar instruments. And we can see things that are really, really faint. And so now I want to go back to what we said about the asteroids. The asteroids are really small. They're really hard to see because the light, let's say that I'm the sun right here. Xander, can I borrow you, please? Okay, Xander, I want you to stand right there. So Xander is my asteroid, right? And I'm the sun. And so light has to come from me to him and bounce back. And all the time it's getting fainter. It's good this, I get to punch him in the face. Okay. Now, what happens though if he's not in the asteroid belt, but he's out by Pluto? I want you to walk all the way up to the first end. So now the light that's coming from the sun has to go all the way back there and then bounce almost all the way back for us to see it. And so Pluto is really hard to find because it's not that big. And it's so far away that it just doesn't reflect much light. You can go back and eat your pizza now. Thank you. And so now we've got this situation where we found this one object. But then we started finding more and more and more of them. And so really whether Pluto should be a planet, it comes along with our understanding of how the solar system is. We used to, 400 years ago, think that the Earth was the center of the solar system. And then we got the evidence to show, no, that's not the case. It's moving around the sun. And then we thought that, that we only had the planets and we found asteroids. And now we found this other set of bodies. And so the idea that we would demote Pluto is really an interesting one, because it's not really a demotion, it's just a better understanding of what it is, and it's actually the prototype of a particular type of body. Now, there's an awful lot more pieces in there, and so I'm going to actually ask you to talk amongst yourselves as to what would you like to know about Pluto and why it's not considered to be a planet? And then I'm going to get each of your tables to ask me a question. Okay?
Everybody in that?
So what was the question?